Hello, honors geometry students. Great to see you. Even though I cannot see you, you're in there somewhere. You can see me. I hope you're okay with that. Today, we're going to continue a lesson on similarity in right triangles. So in my last video, I believe it's been a few days, I just kind of went through, I videotaped the class about when we draw an altitude in a right triangle, how that divides the triangle into three similar triangles. Now, at school, if you were at school, we did significant work kind of using that idea, splitting up the three triangles. We called them Papa Bear, Mama Bear, and Baby Bear, and finding proportions in those triangles, and then relating that to the idea of a geometric mean that we had learned earlier in this semester, and what it means for a number to be a geometric mean of two other numbers, and how we set up a proportion to find the geometric mean of two other numbers. I'm not going to go into that detail in these videos. I really am just I'm going to kind of share two theorems with you that you can use to solve some of these problems. I am going to talk a little bit about geometric means, but this is going to be a lot more bare bones, kind of just the essentials that you need here. So let me go ahead and share my screen. And all I have here is just a white sheet of paper for us to take some notes on. Hopefully you have a notebook of your own that you can use there. Let me make myself a little bit bigger. And hopefully this is, focused. It's kind of hard to tell when all I have is a white sheet of paper, but we are just going to hope for the best. Okay, so here's what we're looking at. We start with a right triangle. Probably should have had this already drawn on my paper here. We have a right triangle, and we'll call that ABC. So angle B is a right angle. And we are going to draw an altitude from the right angle to the opposite side. Remember that side that's opposite from the right angle is called the hypotenuse. Now, the only way that this segment can be called an altitude is if it is perpendicular to that opposite side. So we have a segment that's drawn from the right angle that is then perpendicular to that opposite side. Now, we've already discussed how this divides the big triangle into three similar triangles. You got the big triangle, which is Papa Bear. You got this triangle over here, and I guess I'll call this point D. So this would be triangle BDC. That would be our Mama Bear triangle. And then you got BDA as our Baby Bear triangle. And those three triangles are similar to each other. Now, if I start putting in number values here and then ask you to solve for a certain segment in this triangle, in order to do that, you'd have to write down your three similar triangles and use the fact that they're similar to set up a proportion. Instead of doing that, I'm going to give you a little bit of help. So let's suppose that we're given that this segment from A to D is, let's call it 10. And the segment from D to C, let's say that's 22. And we want to find the length of that altitude, okay? So here's our first theorem that we're going to use today. And it says the altitude, let me go and write this out. I'm going to pause and it's going to magically show up for you. Okay, so our theorem is that the altitude is the geometric mean of the two segments of the hypotenuse. So X is our altitude in this case, and that is the geometric mean of the two segments of the hypotenuse, being the 10 and the 22. Now, what that means is that we can write a geometric sequence. Remember, geometric sequence is one that there's a common ratio between the terms. So we can write a geometric sequence where X, the number we're trying to find, is directly in between the 10 and the 22. That's what geometric mean means, that it's a number in between these two other numbers in a geometric sequence. Now, the way that we solve for that is to use the idea that there's a common ratio between the terms. And so we set up a proportion here. And the first proportion is X divided by 10 should be the same as 22 divided by X. So if you divide any number in the sequence by the number right before it, you should always get the same ratio. So X divided by 10 is the same as 22 divided by X. Now I'm going to go ahead and tell you that from now on, you don't need to go through all of this business every time. We can just set up our proportion here, because you'll notice that the thing that is the geometric mean is diagonal from itself. And then the other two numbers just take up the other two spots. Now, something I probably should have done ahead of time is to rewrite this sentence using the pieces here. So it says the altitude is the geometric mean. So here X is the altitude. So I'll say X is the geometric mean of, so altitude is the geometric mean of the two segments of the hypotenuse, and those two segments are 10 and 22. So X is the geometric mean of 10 and 22. So from now on, when I say that one number is the geometric mean of two other numbers, this is how our proportion is going to end up being set up. The number that is the geometric mean is going to be diagonal from itself, and then the other two numbers just fill in the other two spots. And it doesn't matter which diagonal that you put the X's in, you could put the X's in this diagonal instead. It doesn't matter where you put the 22 and where you put the 10. You can put the 22 there and the 10 there. You can put the 10 there and the 22 there. It really doesn't make a difference. Okay, so in order to solve this proportion, we're just going to use our cross products. And so my first cross product here, X times X, is X squared. My other cross product, 22 times 10, is 220. So to get X, we need to find the square root of 220. Now we're going to give this answer two different ways. One way is to just use our calculators and find the decimal version of that answer, which would be 14.8. If you're at home, you've been absent for a bunch. The other way that we're going to get this answer is in reduced radical form. But if you haven't learned how to do that yet, I want you to come talk to me about that at school in person, and I'll teach that to you. I'm not going to do that on the video, because I want the video to be focused on these geometric mean theorems. Now, let me do just one more that is similar to this one. Okay, so here's another right triangle. I want you to remember that every right triangle has two legs. The two legs make up the right angle. And then you have this third side, which is the longest side, called the hypotenuse. The hypotenuse is across from the right angle. We're going to draw an altitude from the right angle perpendicular to the opposite side. This time, let's go ahead and give you that the altitude is 18. And then let's say this little piece here is X, and this other piece here is 42. Okay, so 42 gets you from there to there, and then X gets you from there to there, right? Okay, so we can kind of write out a sentence similar to this one. And in fact, in these problems, you should always start by trying to set up the following statement, which is what number or some number is the geometric mean, I'm going to abbreviate, of this number and this number. This is what you should be thinking right here. What number is the geometric mean of what other numbers? And what we've learned here is that it is the altitude that is the geometric mean. Here, my altitude is 18. The altitude is the geometric mean of the segments of the hypotenuse. And here that's 42 and X. So 18 is the geometric mean of 42 and X. Once you've got this statement made, you should be able to set up your proportion. Whichever number is the geometric mean. See, here it says 18 is the geometric mean. Whichever number is the geometric mean, that number is going to go diagonal from itself. Now, last time X was the geometric mean. So in our proportion, X went diagonal from itself. Now, 18 is the geometric mean. So 18 goes diagonal from itself. It's the geometric mean of 42 and X. So the 42 and the X just fill in the other spots. And there you go. Okay. Excuse me. We can solve this proportion lots of ways. We could use cross products. X times 42 is 42X. And then 18 times 18 is 324. And so to solve for x, I just need to divide 324 divided by 42, and I get 7.7. Okay, that's one of the theorems that you need to know. We have one more. Okay, so here is our second theorem that we need to know. You'll notice with this one that we are not messing with the altitude. All that happens with the altitude is that this altitude has divided up the hypotenuse into two different segments. Just like it did last time, the altitude divided the hypotenuse into two different segments, but that time we were actually either finding the altitude or we were using the altitude as part of our geometric mean statement. Now, the altitude still divides the hypotenuse, but we don't want to solve for that altitude. We're not going to use the altitude in any way. Instead, we're going to be using and solving for the legs of the right triangle. Okay, so this is different because we're not solving for the altitude, we're solving for the legs. And we're going to do this in two different steps. But first of all, here's your theorem. A leg is the geometric mean of the hypotenuse, meaning the whole thing, and the segment closest to that leg. Now, here's what I mean by that. In this triangle here, I'm going to set up a proportion. A leg is the geometric mean. Now, x and y are both legs, so I can take my pick here. I can either use x or I can use y. I'm going to use x. So a leg is the geometric mean. X is a leg. That means x is the geometric mean of, now this says the leg, which in this case is x, is the geometric mean of the hypotenuse, and that means the whole hypotenuse. Now ask yourself, if this part's 5 and this part's 15, how long is that whole hypotenuse? Did you get 20? Good job. So the hypotenuse is 20. X is the geometric mean of 20 and the segment closest to that leg. Well, here's x. This is the leg we're using. There's two segments to choose from, 5 and 15. Which one of those is closest to x? Did you say 5? Good job. So x is the geometric mean of 20 and 5. Okay, the leg x is the geometric mean of the hypotenuse, which is 20, and the segment closest to that leg, which is 5. Now we know that whatever number is the geometric mean, that goes diagonally from itself. The other two numbers fill in the other two spots. And so here, when I do my cross products, x times x is x squared. And then the other cross product, 20 times 5 is 100. And so I do the square root, and the square root of 100 is 10. So x is 10. Now let's do the same thing with y. Okay, so I'm going to set up a proportion that uses the y. Okay, so y is also a leg of this triangle. Y is the leg, so y is the geometric mean. So the y goes diagonal from itself. The leg is the geometric mean of the hypotenuse, which is 20, and the segment closest to that leg. So the leg I'm using is y. The two segments are 5 and 15. Now ask yourself, between 5 and 15, which of those two segments is closest to the y? Did you say 15? Good job. 15. Okay, so y is the geometric mean, there we go, of the hypotenuse, which is 20, and the segment closest to that leg, which is 15. So there's my proportion. And to solve that, I just use my cross products. Y times y is y squared. 20 times 15 is 300. And so I just need to do the square root of 300, and I get 17.3 for my value of y. So this is how this other theorem works. Okay, I'm going to do one more problem with this one, just so we can practice a little bit. There's my there's my right angle. Drop my altitude down. That's perpendicular. Let's say this side is 12. This little segment is x, and this other segment here is 20. Okay. Now, again, you can see I'm not using the altitude here. I'm using a leg. It is the leg that is always the geometric mean. So I'm going to write out the statement. You don't always have to write this out, but you at least need to think it. 12 is the leg. So 12 is the geometric mean of, okay, for this theorem, when we're using a leg, that leg is the geometric mean of the entire hypotenuse. Now, how am I going to get that? This is 20. This is x. Well, remember what we did last time to get that whole hypotenuse. Remember, to get that 20, we just added the 5 and the 15. Well, to get the whole hypotenuse here, I have to add x and 20, right? So 12 is the geometric mean of the hypotenuse, which is x plus 20, and the segment that is closest to that leg, which is x. Okay, so we're going to set up our proportion here. 12 is the geometric mean, so 12 is going to go diagonal from itself. You can do this diagonal, it doesn't matter. The other two guys make up the other two spots, x and x plus 20. Okay, so we need to solve this thing, which is going to be a little bit tricky. We're going to have to solve a quadratic equation, but it's a good thing for us to practice with that. Okay, I'm going to start with my cross products. My first cross product will be this x times the x plus 20. That's going to look like this. Notice the parentheses there. Equals, my other cross product is 12 times 12, which is 144. Okay, we need to distribute our x. X times x is x squared. X times 20 is 20x. Okay, then we need to get 0 on one side of this equation. So I'm going to subtract 144. There we go. Now, I will point out that you don't always end up with a quadratic equation when you're solving these problems. Sometimes you do, sometimes you don't. In this case, we did. Okay, we need to solve this equation. There's lots of ways that we can solve it. One of them is to use our quadratic formula, and here that is. Boom, our quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let's do it. My a value here is 1, b is 20, c is negative 144. Here we go. The opposite of b would be the opposite of 20, so negative 20 plus or minus the square root of b squared would be 20 squared minus 4 times a, which is 1, times c, which is negative 144. All of that is divided by 2 times a, but a is 1, so that's all divided by 2. Okay, next up, I'm going to come down here. Negative 20 plus or minus. I'm going to use my calculator here to get 20 squared minus 4 times a times negative 144 is 976, goes under the square root, all over 2. Okay, let's figure out what the square root of 976 is, 31.2. So this becomes negative 20 plus or minus 31.2 all over 2. Now we are going to get 2 different solutions here. One of the solutions is going to come from using the plus. The other solution comes from using the minus. So for my first solution, I'm going to do negative 20 plus 31.2 over 2. And to get the other solution, I'm going to do negative 20 minus 31.2 all over 2. Negative 20 plus 31.2 is 11.2 divided by 2 is 5.6. Negative 20 minus 31.2 would be negative 51.2 divided by 2 is negative 25.6. And there is our final solution. Really, what you should be most concerned with right now is getting that proportion set up. The leg is the geometric mean of the entire hypotenuse and the segment closest to that leg. All right, that'll do it. There is some practice that needs to be done on that lesson for sure. So get to it. See ya.